Hello, good day viewers. Welcome to this mathematics presentation. So in this presentation, we are going to look at how we can solve these equations. So we have our first question right here. Solve the following equations. We have 2 raised to the power of 2x plus 1 plus 15 times 2 raised to the power of x minus 8 is equal to 0. So they want us to find the value of x. Okay, so first thing, what you are going to do is we are going to look at this term that you have. Okay, you have 2 raised to the power of 2x plus 1. So you can agree with me that if you have something like this, if you have a raised to the power of x, okay, again you say times a raised to the power of x. So we are multiplying. The base here is a, the base here is a. So same bases. Okay, what do we do with the powers? We add them. So I'm just going to get the single base, which is a. Then we say x plus x. And this will give us a raised to the power of 2x. So having this principle in mind, we can apply it right here. Okay, if you don't want to apply this one, if you have a to the power 2x, you can write it as a to the power x in brackets, again the 2 outside, meaning that if you apply power of the power x times 2, you still get 2x. So you can either apply this principle or this one. On the first one, you still get the same the same answer. So what you are going to do is you are going to separate these two. So you are going to say 2 raised to the power of 2x times 2 raised to the power of 1. Because if we are multiplying indices with same bases, okay, what do? We add the power. So 2x plus 1, this is the 2x plus 1. Then plus 15 times 2 raised to the power of x minus 8 is equal to 0. So you can either apply this one or this one. Now from here, you are going to come to this one. You are going to apply this principle right here. So we just say 2 raised to the power of x squared times 2, because 2 to the power 1, it's just a 2. Then plus 15 times 2 raised to the power of x minus 8 is equal to 0. Now, once you are on this stage, what you should do is you can see you have the common term 2 to the power x. Again, here there is 2 to the power x. So you can say let m be equal to 2 to the power x. So on the term where you have 2 to the power x, you are going to substitute m. Okay, so right here we are going to put m power 2, because 2 to the power x was raised to the power of 2, so it will be m power 2. Then we say it's being multiplied with this one, so it will be 2m. Okay, then plus 15 times, where there is this 2 to the power of x, we are going to put m minus 8 is equal to 0. So from here we can say 2m squared plus 15m minus 8 equal to 0. This is what you have. So from here now, you can see that we've got a quadratic equation. So you can solve this one quadratically, where you can come up with the product. So the product will get 2 times negative 8. This will give us negative 16. Then the sum, we are just going to get the coefficient of this m, which is a positive 15. So the sum is a positive what? 15. So we can come up with the two numbers that we can multiply to get negative 16. We add them, we get 15. So these two numbers are negative 1 times 16. This will give us negative 16. Negative 1 plus 16. This will give us a what? A positive 15. So since we are using the variable m, so this will be negative m, and this will be 16m. So we are going to substitute this right here on the middle. Okay, so I hope you are following. So we are going to write 2m squared. Okay, so I'll just put this minus m plus 16m minus 8 is equal to 0. Okay, so from here now you can see you have 1, 2, 3, 4. You can group them like this so that you factorize. So in the first bracket, what is common? M is common. We can factor out m. open bracket, m into 2m squared, just going to remain with 2m, minus m into m, you get a 1 like this, plus, so whatever that you have here, even in this other bracket, you should have the same once you factorize. So you have 16m minus 8. What is common? You have 16 and 8. The highest common factor of 16 and 8, it's 8. So you factor out 8. Then you only have a single letter right here, so you can't factor out m. Open bracket, 8 into 16, it's a 2. Then there is this m. Positive times negative, it's a negative. 8 into 8, it's a 1. You close, okay? Then equal to 0. So you can see these are the same. So from here, what you can do is just get one expression which is the same. Then you also write m plus 8. M plus 8 equal to 0. So you can now equate each of these two expressions to 0. So you can say 2m minus 1 is equal to 0, or m plus 8 is equal to 0. So we want to find the value of m. So we're going to say 2m is equal to 1. This negative 1 has gone where 0 is. Okay, so we can now work it out. We divide by 2. Divide by 2. M is equal to what? Half. So this is the value of m, or m plus 8 equal to 0, this one. So I can say m is equal to negative 8. So this is the other value of m. Now remember, we are not solving for m, but we are solving for x. So these two values of m, they are going to help us to be able to find the value of what? Of m. So here we said we let m equal to 2 to the power x. So I'm going to take that equation, which is 2 to the power x is equal to m. So the first one we are going to use is this one, when m is equal to 1 over 2. So I'll substitute 2 to the power x is equal to 1 over 2. So for this one, you can see the base here is 2. Here we have 1 over 2. So you can write this, okay, you can write it in this way. So we're going to have 2 to the power x is equal to 2 to the power negative 1. So that this one, we are going to rewrite it in a proper way, in index form, okay, so that we can have the base of 2. Now this one is going to be the power. Now it's going to be a negative, okay. So we can see the bases are the same, even the powers are the same. So this one will be x is equal to negative 1. So this is the value of what? Of x. Now we come to the other one, where we had m equal to negative 8. So for this one, we are going to say 2 to the power x is equal to negative 8. So where there is m, I've substituted with the negative 8. Now for this one, we are going to get the value of x, which is not going to be part of the real numbers, okay, for this one, because you have the base which is a negative what? A negative 8. So the real solution will just be this one, x is equal to negative what? Negative 1. Okay, so we have answered our first one. We can go to the second one. Alright guys, so we've now come to our question 2. So we need to solve 2 raised to the power of x plus 2 raised to the power of 1 minus x is equal to 3. So here we are just dealing with these equations. Okay, so again, the way we are going to write this one, we are going to write it as 2 raised to the power of x plus 2 raised to the power of 1 over 2 raised to the power of x is equal to a 3. Okay, so now where is this coming from? So you understand that if you are dealing with the indices, you are dividing indices that have got the same bases. For example, m raised to the power of a divided by m raised to the power of b. So the bases are the same. So you just say m, when you get the powers a minus b. So this is where this was coming from, okay? So for this to be 1 minus x, it means that they were dividing, they had 2, okay? Then divided by 2 raised to the power of what? X. So for this one now, you can write it in this way, 2 over 2 power x. So this is what I've applied here. Okay, so I hope we are now together. So from this, we can now say, what is the common term? You can see we have 2 to the power x, 2 raised to the power of x. So we can now say, we can let p is equal to 2 to the power x. So where we have 2 to the power x, we are going to substitute p. So you can say on this one, we are going to have p plus 2, because 2 to the power 1 is just a 2, over, where there's 2 to the power x, we are going to put a p equal to a 3. Okay, so I hope that you are following. Then from here, we can do this. Since we've got a fraction here, we can multiply everything. Okay, we can multiply everything with a p, this one. So p times p, we are going to have p squared plus this p and this p will cancel. You just remain with a 2 equal to p times 3, you get a 3p. Okay, so from here we can collect the like terms. We can say 2p minus 3p plus 2 equal to 0. So here what has happened here is that this 3p has gone to the left hand side. It was a positive, it has become a negative, then plus 2 equal to 0. So we have a quadratic equation. So here we can now solve this one quadratically. So we can find the product and the sum. Okay, so here our product, we can say product is equal to the coefficient of p squared is it's a 1. So 1 times positive 2, you get a positive 2. Then the sum, you just get the coefficient of p right on the middle, which is a minus 3. So negative 3 is the sum. Now look for two numbers such that when you multiply them, you are going to get a 2. When you add them, you get a negative 3. So these two numbers are, if you multiply negative 1 times negative 2, you get a positive 2, which is this product. Negative 1 plus negative 2, you get a negative 3, which is this sum right here. So since our variable, it's a p, so this negative 1 will be a negative p, and this negative 2 will be a negative 2p. So this is what you are going to substitute right here on the middle. Okay, so we are going to write p squared. So on the middle, I'll just substitute that, which is minus p minus 2p. Okay, then we say plus 2 is equal to 0. So from this, we can group these terms like this. Then we can factorize. So in the first bracket, what is common is a p. We factor out a p. P into p squared will remain with a single p, minus p into p, you get a 1. So minus whatever that you have here, even here when you factorize, should be the same. So minus, you have 2, there is a 2 here, so 2 is a common factor. Okay, 2 into 2p, you just remain with a p. Negative times positive, it's a negative. 2 into 2, it's a 1. Then equal to 0. So you can see they are the same. So you can just say p minus 1 and p minus 2 equal to 0. So from here, we can group them. We can say p minus 1, we equate them to 0, or p minus 2 equal to 0. Alright, so from here now, we can say p is equal to 1. This negative 1 has gone to where 0 is. It has become a positive. So 0 plus 1 is a 0. Or p is equal to 2. Negative 2 has gone to where 0 is. It was a negative. It has become a positive 2. So these are the values of p is equal to 1 or p is equal to 2. Now remember, we are solving for x. Okay, we are solving for x. This was the original question. So we can get this where we said we let p to be equal to 2 to the power x. We can get that equation so that we solve for x. So p is equal to 2 to the power x. Okay, we can solve for x when p is equal to 1 for this one. So we are going to say where there is p, we are going to put a 1. 1 equal to 2 to the power x. Okay, now here we want to make sure that if you have the base of 2, even here the base is a 2. So what we can do is we can apply one of the laws of indices. If you have a to the power 0, it will give you a 1. Okay, so again, if you have the base is a 2, if you have 2 to the power 0, to give us a 1. So we can get this 2 to the power 0, you substitute there, 2 to the power 0 is equal to 2 to the power x, because we know that 2 to the power 0, it will give us a 1. So the essence of doing this is to make sure that the bases are the same. So if the bases are the same, even the powers are the same. So therefore, x is equal to 0. Okay, so we have solved for the first value of x. We can now get the same equation. We say p is equal to 2 to the power x when p is equal to 2, because we found two values of p. Okay, so where there is p, we are going to put a 2. 2 equal to 2 to the power x. So this one, the bases are the same. It means this 2 is having a power of 1. So therefore, x is equal to 1. So the final answers now, we can just say, therefore, x is equal to 0 or x is equal to 1. These are the values of what? Of x for our second question. So I hope it's clear. Okay, so make sure that if you have a comment, you leave it in the comment section. So thank you so much, everybody. This has been your presenter, Mr. Mlenga. Bye-bye.